Hi, good evening all. And today we are here for a session in which we'll be discussing about the frequent changes that have come in the CBSE pattern. So I just want to confirm, am I audible to all of you?
Yes, ma'am, you are.
Okay. So welcome and let's start the session, and we'll be taking chapter 1, that is real numbers here. So here we have a set of 20 questions in which we have tried to incorporate the new changes that have been given by CBSE, and hence we have framed 20 questions according to that. So you will see that we have questions in which we have some choices and we have to use our concept to solve these questions. So let us try to solve the first question here. And the first question says that 3 runners can finish one round of a circular running track in 100, 90, and 150 seconds respectively. If they all started at 6 a.m., when they will be side by side next? So what we need to understand here, that we have 3 runners and these 3 runners are running on the same track. So let's suppose the track is this one, because they have given the circular running track is here. And these tracks, the 3 people are covering in 100 seconds, 90 seconds, and 150 seconds respectively. Now, if they all start at 6 a.m., when will they be side by side next? So we have to tell that suppose they all start from this point at 6 a.m. At some point in future, they will again be together. So we need to find at what point of time they'll be together again. So as we can see that the first person is taking 100 seconds to complete the track. So suppose after 90 seconds, he is here, right? But what we see that the second person has completed the track in 90 seconds. So it means he will be somewhere here when the 90 seconds are done, because he has completed the circle. The third person is taking 150 seconds. So it means that at 90 seconds, he will be much behind and he will be somewhere here. So we can say that this is A and this is B and this is C at 90 seconds. Now, what we want to know that when they all will be together again. So one thing is obvious, that within 150 seconds, they cannot meet, Because what we see that the first person would just have completed the first round and the other two people would be somewhere else. So how can we find it? We get the first clue that whatever answer we are looking at is greater than the largest of the three. Right? What is it? It is greater than the largest of the three. And this gives us a hint that we have to go for LCM. Now, if we want to find the LCM of these three numbers, what should we do? We will just take the prime factorization of these numbers. So I hope we can do the prime factorization really quick. So prime factorization of 100 would be, if we take with 2, it is 50. Then again, we'll take with 2, we'll divide it and we'll get 25, and further 25 is 5 times 5. So in powers, we can write that it is 2 square times 5 square. Similarly, if you do the prime factorization of 90, you will get 2 times 45, you'll get 3 times 15, you'll get 3 times 5, and finally you'll get 5 times 1, which is 2 times 3 square times 5. And for 150, what we'll get? We'll get 2 times 75. This is 3 times 25, and 25 further is 5 times 5. So we are getting 2 times 3 times 5 square. Now, if we want to see that what is the LCM, we should take all the possible factors that we see in any of the numbers. Like we are seeing 2, we are seeing 3, and we are seeing 5, and we'll put the largest power. So 2 square, because the highest power of 2 is 2. The highest power of 3 is 2. And the highest power of 5 is 2. So LCM of these three numbers is this. And if we solve it, we'll get 4 times 9 times 25, which is equal to 900. So it means that after 900 seconds, all the three people will be together. But they are asking the time again. So we need to change it into minutes. And in minutes, if we change these 900 seconds, so 900 divided by 60, because each minute has 60 seconds, we'll get 15 minutes. So now can we guess the answer correctly? So answer will be 6:15 a.m. That is 15 minutes after 6 a.m. I hope the explanation is clear. And hence, we'll move to the next question. So the next question that we have is again on HCF and LCM. And the question is, we have been given the HCF of two numbers, and the two numbers here are 250 and P. And the HCF is given to us as 5P. What is the LCM of these numbers? So here we need to use a rule that we have read, and the rule is that HCF times LCM of two numbers is equal to the product of these numbers. Right? Now, HCF of the two numbers is given to us as 5P here. So we can put it over here. LCM of the two numbers is unknown, that we have to find. And product of the two numbers are given to us as 250 and P. Now we can solve it. How? In order to find LCM, on both the sides we can divide by 5P. So on the left hand side 5P will be gone, and on this side we'll get in denominator 5P. So P and P gets cancelled, and this is 50. So we can see the LCM of these two numbers is 50. So I hope this question is also clear to you. If you have any doubts, you can let me know. I'll explain again. So you see, these kind of questions are something that we don't see in our textbooks regularly, but these are important from the point of view of our exam, the upcoming exam, and the changes that have come. You may also refer the courses that we have from the super teacher, and this will really help you. So I'll just guide you once how you can go to the courses. So like you open your browser and just write super teacher, and you can also use the super teacher app. Here I'm showing you how you can use the super teacher website that we have. Now once you come to programs, you can go to students. You can choose whatever you want to learn. Here I'll guide you how to choose the CBSE subject, and like you can go for grade 10 science and mathematics. You can inquire more. We have a 24 hours toll-free number where you can call and ask, inquire about any kinds of like doubts you have. I just want to say that in these courses, we'll be giving you the live sessions. Also, we'll be covering everything. Like you can see, all the topics have been mentioned clearly here. In addition to this, you will get a lot of questions, test series, and also PDFs to refer. So in case you are interested, feel free to call us, and you can also book a demo class and register. Okay. So any doubts, please feel free to call us. Coming back to our questionnaire, I hope you all are enjoying, and we have done 2 questions so far from chapter 1. Now the third question that we have again is a very interesting question, and we have a very important term here, which is co-prime. So like it's very important to know what is co-prime. So whenever we see this number term co-prime, we should understand that what are co-prime numbers. So one thing you remember, whenever we say co-prime will be more than 1. We are talking about 2 numbers, 3 numbers, right? We are talking about a set of numbers which are defined as co-prime, and co-prime means that all the numbers have only and only one common factor, which is 1. So in the other word, you can say that the highest common factor of all co-prime numbers is 1. Now, since they had given us something related to co-prime, we have written HCF equals to 1. Now let's read the problem. 5a and 3b are co-prime numbers. If their LCM is 750, which of the following is the correct value of a times b? So since I have done a similar question just now with you, I would like to give you a minute, try it out, and then we can discuss the problem here. So please try it out. It's very similar to the previous problem. So the law that we'll be using over here is the same, that HCF times LCM is equal to the product of numbers, right? So the HCF over here is 1 because the numbers were given to be co-prime. LCM is given in question to us, which is 750. The product of numbers can be easily found as the numbers are given, which is 5a times 3b. So what we'll get? We'll get 750 is equal to 15ab. So what we got something like AB is equal to 750 over 15. What I've done, I've changed the sides. I've brought this to the left hand side, brought this to the right hand side, because generally whatever we want to find is on the left hand side of the equation. Nothing else. Like it is totally fine keeping in this way also. So now when I divide, 15 ones are 15, 15 fives are 75 and a 0. So we get 50. So in the question also they were asking the product of AB. Here also we have calculated the product of AB, which is 50. So hence the option A is the correct one. Yeah, thank you. Whatever, like Fareen, you answered it well. Tanima, you answered it well. It is 50 also. Thank you. And well done. Let's go on to the next problem. And the next problem, yeah. So what does the next problem say? This question is a very, very important question, and you see a new type of question, very different from what you find in NCERT books. The question is based upon two statements. Here we have two statements, a statement A, which is an assertion, and a statement R, which is a reason. Let me just walk you through what we mean by assertion and reason. So assertion and reason question means that there are two statements, and in the first statement, which we are calling assertion, we are putting up a statement. We are saying like a statement which you have to check as a fact. And in the reason, we are giving a statement which explains the assertion. Okay, so first you have to read these two statements, understand the two statements, and then conclude which of the following options will work. So first option, you have to check if both the statements you find are correct and you feel that the reason which is given is a correct explanation of the statement one, that is assertion. Second, you have to check when both these statements are correct, but you don't see that reason is the correct explanation of assertion. C is when the assertion is correct, but the reason is not correct. And the last option is when assertion itself is not correct, but you see that the reason which they are mentioning is correct. So here, the first question that we have of this type is, the LCM of two distinct prime numbers is simply their products. So first we have to check the truthfulness of this statement. Do we find this statement is true? So let us take it by any example. So they are talking about two distinct prime numbers, and let's take any two distinct prime numbers. So I'm okay by taking 2 and 3, the smaller ones. And what will be the LCM of these two numbers? So by taking the prime factorization, 2 can be written as 2 to the power 1. 3 can be written as 3 to the power 1. So LCM will be whatever possible factors are present and raising to their highest power present. So highest power of 2 is 1 and 3 is 1. So we get the LCM as 6. Now, the LCM of two distinct prime numbers is simply their product. We get it, right? It is correct, which is also coming to be 6. The reason which they are mentioning is any two distinct prime numbers will always be co-prime. So you see that these two numbers don't have any common factor. Like if I want to find the HCF by prime factorization, I have to check what are the common factors here. So you see that the common factor is only 1. So hence I can say that the reason is also correct and the assertion is also correct. It can be verified by the law which we were taking, that LCM times HCF is equal to the product of two numbers. So even if you take this, then also the statements are true. So for this, we'll get the answer as A, which specifies that both A and R are correct, and R is the correct explanation of A. Now let's move on to the next question. So fine, I'll give you 1 minute to try this question and then we'll again discuss. Please take 1 minute to go through the question. I hope the question is still visible to you. Okay, we already have some answers, it seems. Let everybody try. Okay, so let's discuss the problem now. The question says there are 375 guavas, 150 oranges, and 225 apples were distributed among some people. If everyone got the same number of each fruit, how many people were there? So if you see, first thing is we are very clear that this question is from the topic of HCF and LCM, right? The biggest doubt that appears and comes into our mind is which one should we find? Should we find the HCF or should we find the LCM? So the easiest way to think about this is that everyone ate exactly the same amount of item as any other one, right? Now, if we go on to find the LCM, the answer will be greater than 375. We know that LCM of any three numbers will be greater than the greatest number. So is it possible that any of the people will have more than 375 fruits? The answer is absolutely no. So what we understand that here we have to find HCF, right? So this is an easy way to check if we want to find HCF or LCM. So it's correct. Most of you are answering it correct that we have to find the HCF here. And how will we find the HCF? Quickly, can you help me with the prime factorization? So prime factorization of 35, if I say, will be 5 to the power 1 and 7 to the power 1. Okay, 45 is 5 times 3 square. Okay, just a second. I took the wrong numbers. Now I want to take the first number, which is 375. And 375, if I prime factorize it, it will be how much? Yeah, 5 into cube times 3. Okay, what about 150? What about 150? It will be 2 times 3 times 5 square. If I talk about 225, what will it be? It will be 3 square times 5 square. Now the HCF is the only common amongst all. So you see 2 is not common in all, so we won't take the power of 2. We'll take 3 and we'll take 5. So the smallest power of 3 that we see anywhere is 1 and the smallest power of 5 that we take anywhere is 2. So we are getting 3 times 25 and hence the answer is 75. So the answer will be D. I hope it's clear to all of you. Fine. Let us do the next problem. And the next problem is again a very important one. It says that HCF of three numbers. Now the three numbers are not given to you. The three numbers are given in the form of some unknown variables. So HCF of three numbers P, Q, R is Z. Which of the following will be the HCF of 2P squared, 2Q squared, and 2R squared? Okay, I'm getting some answers as 8Z squared. Let's see more. Exactly in 30 seconds, I'll start the discussion. You may focus on question more for next 30 seconds. Okay, I'm getting one more answer as 4z square. Fine. So let's start. What we see that the HCF of the three numbers is given to us as z. So we'll take the first number, something with product of z, like I can say that p is equal to a times z because z is still there. If I want to assume q again will be b times z. You see the only common factor between p and q is z. And for r, let us assume it is cz. Fine. Now what are they saying? What will be, which of the following will be the HCF of 2p square, 2q square and 2r square? So now if I say 2p square, it will be 2 times a square times z square. If I say 2q square, it will be 2 times b square times z square. And if we talk about 2r square, it will be 2 times c square times z square. Now can we say what is common in all three? So the common in all three is 2z square, and hence your answer was absolutely correct. So many people could answer it correctly. Really nice. So all of you who had a doubt of considering 8z square, I hope it's clear why it wouldn't be 8. Because we take the common term. We don't have to take the product of the common term, right? Okay, well attempted. If you want more of such questions, you can surely subscribe to our courses, register for our courses and have a lot of such questions to try on. Please remember this time CBSE has given some changes in the paper where we have 40% of competency based question. They will not be asking you questions directly, but you will get some questions of the form that we are discussing. If you want to practice more of such questions, you may register on our portal. We have an app also, and we have website also. On both, you can register and get more of such questions. Okay, let's try out this question again. So the next question that we have is, okay. I'll just put it to share again. I hope my screen is visible now.
Yes, ma'am, it's visible.
Okay, thank you. So let us start with this question. It says x, y, and z are all distinct positive integers such that x is the HCF of x and y and z, x and y, and z is the HCF of x and z. What is the HCF of x, y, and z? So you see that this question has a little of trick in it. We have the numbers x, y, and z, and such that x is the HCF of x and y. So the first two numbers that we have, x and y, x itself is the HCF of x and y. Can you think of such an example? Like if I say x is equal to 2 and y equals to 4, the HCF of x and y is x itself, right? True or not? Further, they are saying that z is the HCF of x and z. Now, if you take x as 2, what can be z if the HCF is z only? Since it is a prime number, the only possibility of z is to be 1. Correct or not? So the HCF of 2 and 1 is 1. Now they are saying if you take x, y, and z. So we have taken an example in which we are taking both the conditions to be true. So from here only we can take x as 2, y as 4, and z as 1. Now can you tell me what will be the HCF of x, y, and z? Can anyone answer? So let me see. Yeah, so Farheen, and we have few more answers. Tejaswini did. So it's correct that C is the correct answer, which is Z. I hope the explanation is also clear to you. Nice, nice tries. Let's move on to the next problem, which is problem 10. A very, very, very good question. I'll tell you all, these type of questions are not available in general textbooks, in reference books. These questions are actually very well thought of and made only for your preparation. If you want more of such questions and practice this way, please log in and register to our website or app and practice these questions. So what are they saying? They're saying that there are two rational numbers. We know what are rational numbers. Rational numbers are numbers that can be expressed in the form of P by Q, where P and Q both are integers. So here they have given us X, which is equal to 45 over 288, and Y is equal to 225 over 270. Now, one very simple question before reading on the problem. Do you see X and Y are in their standard forms? Standard form of a rational number is when the numerator and the denominator are co-prime, means they are in their simplest form. So do you see that X and Y are in its simplest form? And if you see that it is not, then can you tell me what will be the simplest form of X and Y? So I'll give you 1 minute. Check out the simplest form of X and Y both. So like the number X and Y, the numerator and denominator can be divided by. So if you check this one, if I divide by 2, it's not possible. If I divide by 3, for numerator, denominator, both it is possible. So I'll get 15 and this will become 9 and 6. Further, right? Again by 3, I can cancel it out and it will become 5 by 32. So now this is the standard form, the simplest form of this rational number. Similarly for Y, can you quickly tell me what will be the simplest form? So let's divide by 5 and we'll get 45. And this one will be 5 and 4. Further by 9, we have 9 5s are 45. And this will be 9 6 are. So 5 by 6. Now let's move on to the question. Which of the following has a terminating decimal form? So if you do X plus Y, the first case, then it means you are adding 5 over 32 and 5 by 6. So do you think that we'll get a terminating decimal form? For terminating decimal form, the denominator should be of the form of 2 to the power m times 5 to the power m, where m and n belong to whole numbers. Means they can be anything from 0, 1, 2, 3 and so on. Apart from 2 and 5, there should be no other factor for the denominators. But here what we see that 5 over 2 to the power 5 we have, but for 6 we have 2 times 3. So it means that when we do X plus Y, we cannot get a decimal which is terminating. Let's try out with X divided by Y. So if I talk about X, it is 5 over 32. If I talk about Y, it is 5 over 6. But since we are dividing, we'll put reciprocal. And now this. So what do you see that 5 and 5 is getting cancelled and we have in denominator 2 to the power 5, which is obeying our condition for this denominator. Like you have 5 to the power 0, which is a whole number, and 2 to the power 5, which is again a whole number. So from this one, we can say that it will have a decimal form, which is terminating, right? I hope this is clear to you. If you have any doubts, I can repeat again. Okay, let's move on to our next problem. And I'll give you 1 minute to think over this. Please read the problem carefully and try to understand what they are asking. For the previous question, I think I have a few requests to repeat. So I'll just take that up. So fine, if you have done the previous problem, it's the last problem, it's fine. But as you have requested, many of you, I'll just take this question again. So in this question, you might have understood that how we are taking the standard form, and in standard form, the numerator and denominator have to be simplified, right? So we have the first number, which is 5/32. And the second number y as 5/6. So till here we have no doubts, right? I want to tell you that the question is asking which of the following has a terminating decimal form. So terminating decimal form means the denominator can only have 2 and 5 or their powers. Okay, we should not have any other factor in the denominator. Now, if you do x plus y, like we are going option wise in this question. So if you do x plus y, we have 5/32 plus 5/6, which is 5/2⁵ plus 5/2 times 3. So surely when you will take the LCM, what will you get? You will get 2⁵ times 3 as the LCM. So here, whatever answer you will get, there will be something, whatever answer you will get, its denominator is having a factor 3. Agree? So if we are getting a factor like 3 in the denominator, it cannot be terminating. Because the rule is we can have only 2, we can have only 5, or we can have only 2 and 5. But we have 3, hence option A is not possible. Now coming to the option B, which is x divided by y. So x was 5/32 and we are dividing it by 5/6. So which is 5/32 times 6/5. So here you see in the denominator we are getting 2⁵. 32 is what? 2⁵. So this will surely have a terminating decimal form, right? So hence we can say that this particular thing will give us a rational number which will have a terminating decimal form. Is it clear to you now? I hope it's clear. And in case you have any doubts, you can connect to us further also. After the session also, it's possible to connect to us. Please don't hesitate in case of any doubts, okay? So we were here on this question. And in this question, what they're saying, the ratio of number of boys to the number of girls is given below. Which of the following could be the number of boys and girls respectively? So basically, what they are telling you that you had a fraction like number of boys and number of girls. So instead of writing numerator and denominator, let me write that we have boys divided by number of girls is equal to 1.012 and the bar is over 12. We need to guess the number of boys and number of girls, right? So one thing is like we can go by the options and we can divide and we can then find. But I'll tell you this can be very, very long process. Okay, like in the first case, it is not possible because it is simply 1.012 divided by 1000, it was there. But for the remaining 3, you have to divide by numbers like 999, right? And you won't be able to guess the answer that way. So let's see how we can do this. First, what we'll take, we'll try to change this particular number into fractional form. And let's see how we'll do it. So in the first step, we'll say let x equals to this particular number. Fine. Now, how many digits are repeating here? We have 2 digits repeating. So we will take 100x. If there was 1 digit repeating, we'll take 10x. If there are 3 digits repeating, we'll take 1000x. The number of zeros in this depends upon the number of digits which are repeating. So if we take 100x, we'll get 101.2121 and so on. Right? So let me write 100x first. So 100x is equal to 101.2121 and so on. And if I write the value of x, let me write decimal below decimal, 1.012, and again we'll have like 1, 2, 1, 2 and so on. If I take the difference of these two, I'll get 99x. 100x minus 1x is 99x. And this side you see, after these 1 and 1, in fact, this 1 and 1, everything will cancel. Yeah, say please. You can message me whatever doubt you have. Somebody was raising a hand. Right, you can please directly message me, okay? So 100x minus x is 99x. And here what we'll get is 100.2. So it is saying, can we cancel it from the whole number? As in, no, see, I'll just want to tell you why we could do this, because it's 1, 2, 1, 2 and repeating the same way, right? We'll get the same digits. So we are not cancelling, actually we are taking subtraction. So 2 minus 2 is 0, 1 minus 1 is 0, 2 minus 2 is 0. So simply we can say all the numbers which are coming in line are same. Yeah, only same number we can say are getting cancelled. And we know that after decimal, if there is a number and then followed by zeros, it doesn't make sense, right? It is same, right? So hence, if we could cancel it easily and it does not change the number. Now 101 minus 1 is 100. So we got this. Now it's simple, right? 99x will be 1002 over 10. And when we divide 99 on both the sides, it becomes 990. So now you can easily guess the answer. What is it? We got the value of x as this. Can you guess the value of boys and girls? 1002 over 990. So the correct option is option B, right? Okay. I hope it is clear. If it is not clear, you can ask me again. You can put up your specific doubt in the chat as well. Okay, let's proceed to the next problem. Okay, I'll just remove the drawings. Yeah. So what they are saying, again, this is the assertion reason type question, very important. And you should know how to deal with these questions. So as I told you, you will have 2 statements. And by looking at the 2 statements, you will have to analyze the 2 statements and comment on which of the options is correct. So what is saying? P and Q are positive integers. There are 2 integers, P and Q. Now, the first statement that we have is, it is possible that P by Q has a terminating decimal form in spite of Q having other prime factors than 2 and 5. So they are saying that P and Q can have terminating decimal and this denominator has some other factor also. So do you think it is possible? Do you think it is possible? Yes, it is possible if in numerator we have the same factor, right? So it is not possible when the given fraction, the given rational number is in the standard form, when the numerator and denominator are co-primes. But in case they are not co-prime, it is very well possible, because it might so happen that the other factors gets cancelled by the factors of the numerators. So we see that it is true. You can have any other factor than 2 and 5, but it will be a special case. But yes, it is possible. Now, the second thing is P and Q are not co-prime. See, I said just now that if P and Q are not co-prime, then only it happens, and they are giving it as in the reason. So what should we say? Which of the options is correct? Excuse me. Which of the options is correct? Any answers? Okay. So if you have understood well, you might have got it that it is only and only possible when P and Q are not co-prime, then P and Q can be having a terminating decimal form, because you see the other factor will be getting cancelled by the factor of the numerator. Let's try out the next problem, please. So the next problem here says that you need to observe the 4 numbers given below, and you have to say which of them is irrational. So let's revisit what is the definition of a number which is irrational. So either we'll find it in a root form, and here we'll see a non-perfect square, right? If the power is like only we are saying square root, then we have a non-perfect square inside it. Or if it is in a decimal form, then it should be non-repeating and non-terminating. So first thing is, just by looking at the definition, which of the options are omitted? So we see that option R is omitted because it is a terminating decimal. So surely it is not to be included. Further, if you see option S, it is also repeating. So this also cannot be there. Now, is 5 a perfect square? No. So it will be a irrational number. Similarly, 125 is also not a perfect square. So it will also be a irrational number. So can you say which is the correct answer? Can you say which is the correct answer? It is option B. Because you see inside the root signs, we are having non-perfect squares, and hence these numbers when solved will give us decimals which do not repeat and do not terminate. In the other two examples, we had decimals in which the first one was terminating and the last one, this was repeating. So these cannot be the correct answers, right? Any doubts, anyone? Okay, if we don't have doubts, we'll move forward. Wow, very nice question. Based on operation of irrational and rational numbers, you have to give it a lot of thinking and then only you can solve it. I'll give you 2 minutes just to think how will you go ahead with the problem. Let's see. Just think how will you go ahead with the problem. You have been given expressions. The first expression is P minus Q times P minus Q. So we can write this one as P minus Q whole square, right? And this is P plus Q times P minus Q. So we can write this as P square minus Q square. I hope you all understand that these two identities are different, and P minus Q whole square is not same as P square minus Q square. Now they are saying that this is rational and this is also rational. Okay, like you are getting the answer as a rational number for both of these. Which of the following set of values is valid? So let us first understand that if P minus Q square is rational, then it means that p square plus q square minus 2pq is rational, because you won't have any irrational terms in any of the three. And p square minus q square is irrational, means that p square itself does not have any root signs and q square also does not have any root signs, and their difference also does not have any root signs. So now I have given you a lot of hint. Think which of the options will work here. Please check it out. Which of the options will work out here? So let's see option by option. For the A option, P is root 2, root 12. So root 12 square will be 12. Root 3 square will be 3. Minus 2 times root of 12 times 3 is 36. Right? So what we'll get? We'll get 15 minus 2 times 6. Right? Root 36 is plus minus 6. I'm taking plus 6 over here. And you get a rational number. So it is okay with the first condition, right? Now let us check with the same values the second condition, which is p square, that is root 12 square minus root 3 square, which is equal to 15. So it is also fine, right? So we were lucky enough to get option A only as the one which says that both p and q, root 12 and root 3, will satisfy both the conditions. I'll just tell you one thing over here. Remember, even if we have a number inside root, the square of it will always be a whole number. Like if you had root 12, p square will be a whole number. If you have root 3 square will be a whole number, that is 3. Same goes for p square, q square in the second identity. The only matter of problem is this term pq. Right? Because sometimes, like in the second example, if you consider, you will get PQ as root of 96. And root 96 is not a whole number, right? It is not a whole number. So that is why it will not give you something as a rational number. You cannot solve it. It is an irrational number. And hence it does not obey. So basically, the thing is that root of PQ should come out to you as a perfect square, and which happened over here. 12 times 3 came 36, and hence the option 1 was fine. If you check out the other examples, like 24 times 4 is 96, which is not a perfect square. 36 times 5 is 180, which is again not a perfect square. And 48 times 6 is 288, which is again not a perfect square. So the only term which will pacify for these two conditions to give a rational result is option A. So if you have any doubts, you can ask me again, I'll explain you. Or if you don't have, we can proceed further. So can we proceed? Any doubts in this particular problem? A very nice problem, very different from what you will see in the regular books. This is a very recent change which has been given by CBSE, and we have tried to incorporate all these changes in our sets, and like the test series we have, the live sessions we have. You can surely register for any of the courses and benefit yourselves with these type of questions. See, the concept which is given in syllabus is only covered. Only the type of question, the competency based question, is taken over here. Fine. So again, we have a assertion reason question. Let us try to solve it. I'll give you 1 minute exactly to think and answer me. Let's try it out. Fine. If you're done reading the problem and you could understand the statements a little, I'll just give you a little more hint about these statements. The first statement, which is the assertion, says The square root of all composite numbers are irrational. So it is saying that you take any composite number, the square root of it will be irrational. So do you think it is true? What are composite numbers? The natural numbers are divided into prime numbers and composite numbers. So whatever numbers are not prime are composite. For example, number 4, number 6, number 8, number 9, and number 10, and so on. They can be infinite numbers. So they're saying if you take all of these numbers, the square root of these is irrational. Do you think so? No, because we see that there are composite numbers which are perfect squares, and when we take the square root of it, we have what? We have rational numbers. So obviously A is incorrect. So option D will be the correct answer, but let's go on and read the reason also. Not all composite numbers are perfect squares. So it's correct that we have some of the composite numbers resulting to the square root resulting to irrational because they are non-perfect squares. So that's fine, right? Why I have told you to read the reason also? Because you see, there is no hard and fast rule to frame the assertion reason questions. You might have an option E in which it says both A and R are wrong, right? So in that, you will have to take the E problem in case the reason is also incorrect. So please don't go by any shortcuts. In competency based question, you have to be like working ahead of what you can think of, right? You have to work a little step ahead. And for that, you need a lot of practice. And these are the questions you must try out. Okay, fine. We have a assertion reason question again. And I really want you guys to answer this time. Try it out. Please try this problem and answer me. You can reply me directly on the chat box. Come on, let's try. Yeah, in the previous problem also many of you have answered. That's really nice. Ranvil was very correct. He answered D only. Let's see this one. Okay, we already have a few answers. Let's wait for some more answers. So I'm getting a few answers and I think we can discuss it now. So for the statement 1, which is the assertion, it says that product of this is a rational number. Let's find out the product. So which identity will we use to find the product of these two? By A plus B times A minus B, which is A square minus B square. And we get 4 minus 3, which is 1. So do you think it is a rational number? Yes. So obviously A is correct. So D option cannot be the correct answer. We have to choose one of A, B, and C because we say that assertion is right. Correct? Now, product of any two irrational numbers is irrational? I don't think so. If you have root 3 and root 2, these two are irrational numbers and product of this is irrational again. So R is incorrect. So what we'll say that A is correct, but R is incorrect. So hence the answer is C. Very well answered. Most of you answered it very correctly. I'm really happy to see you answering these questions so fast. Let's try out the next problem. And this is a very important problem which is based on case study. So understand the case, and very first thing is identify which topic this problem is from. The first thing you need to do is you have to identify the topic correctly. So have you identified the topic? Message me. Tell me if you have identified the problem, the topic from which it is taken. Very good. It is taken from HCF and LCM. Let's go on. It says that a shopkeeper had the following stationery items available with him. He had 720 pencils, 96 sharpeners, 240 erasers, and 144 rulers. He plans to pack all of them into identical kits to be sold, such that each kit had all of the above items. So, first thing we have to understand is that the shopkeeper wants to make kits of these items, and he wants to put up same number of items in all. So I'll just put in for you that the number of pencils were 720. Then the number of sharpeners were 96. Sharpeners were 96. The erasers were 240. The erasers were 240. And finally, the rulers were 144. The rulers were 144. So you have to take in account this information and tell me what could be the maximum number of kits that can be formed. What will you find? Will you find HCF or LCM? Answer me. What will you find? You'll find HCF or LCM? Very good. We'll find HCF. Quickly, let's see what is the HCF of these numbers. So if I write the prime factorization of 720, it will be 2 to the power 4 times 3 squared times 5. For 96, it will be 2 to the power 4 times 3. For 240, it will be 2 to the power 4 times 3 times 5. And for 144, it is 2 to the power 4 times 3 squared. Right? Now from here, we have to find HCF. So HCF is only the common factors. So we'll take 2 and 3 only because 5 is missing in this and this. And the lowest power. So lowest power of 2 is 4 and lowest power of 3 is 1. So the answer is 48. That is option C. Very well answered. So is this solution clear to you guys? Were you able to follow? See, we did a case study based question that seemed a little difficult, correct? Are you ready for the next one? Let's try it out. So the next question we have is this one. I'm not going to clear the things because we have a few information given in the case study question, the statement. So the next question is this. And in this one, they are saying, while making this kit, 24 rulers broke. So the new number of rulers that we have is, can you tell me? Initially it was 144 and now 24 broke. So it is 120. Correct? So the prime factorization of 120 will be how much? Yeah. 2 to the power of 3 times 5. Because it is 24 times 5, so I have written 8 times 3 times 5. How many pencils will he need to pack in each kit now? So we'll have to go for the what? First we'll find the HCF. So what is the HCF? That is the only common factor, which is 2 and 3. The lowest power of these, which is 3 and 1. So it comes out to be 24. So it means that he will be able to make 24 kits now. Now they're saying that how many pencils will he need to pack? So how many pencils will be there? Total number of pencils is 720. And in how many kits are there? 24. So in each, he will have to pack 30 pencils. I'll tell you, sometimes they'll give an option which is equal to 24 also. So you got 24 as the HCF and you'll mark the HCF. But remember, it is not asking you HCF directly. It is asking you that if this many kits are there, then how many pencils are there in each kit, which we'll find by dividing. Is it clear to you guys? Fine. So the correct option is option C. Let us proceed to the next problem. And okay, the next problem again is here for you. Try it out. If he added an equal number of ball pens, so like he has added an equal number of ball pens in the kit, how many ball pens did he add in total? Yeah. So we'll first take the initial case only, which was for 144 rulers, right? And the 144 can be written as 3 to the power 4 times 2 to the power 4. Sorry, 3 to the power times 2 to the power 4. And now they're asking us how many ball pens did he add in total. Please do this question. So if you are done thinking, I'll just tell you, in the very first case, we found that HCF of this was coming 48, and it means that he was able to make 48 kits, right? So you can just imagine it like he has 48 kits like this. Now they're asking how many ball pens has he added in all. So it is his choice, right? He can put up one ball pen in each. So he'll have to add 48 ball pens in all. He can also choose to add 2 ball pens in each. So in that case, he'll have to add 96 ball pens. So it can be any answer but a multiple of 48. Now can you answer what will be the correct answer for this one? D. Very good. Because we have to take the multiple of 48. If he chooses to add 1 ball pen in each, then 48 is fine. But if he chooses to add 2, then it will be 96. If it is 3, then it will be more, and so on. Right? So this was like one of the case study questions that we have discussed. And we have one more case study question which is very interesting. Are you all ready for that? It will be the last major question for today's session. Reply me yes if you still want to do it. Yes. More answers. Good, good, good. So this is the case study 2 which we'll be doing here. And it says that we have an incomplete factor 3 of 3 numbers here. And obviously you'll have questions which will proceed according to this. So let's see that what are they asking. Which of the following is the HCF of P, Q, and R? So basically they're asking us the HCF of P, Q, and R. So let's do one thing. Quickly, let's complete the factor tree. Can you complete the factor tree? Yes, we can. And the way to complete it is go from the bottom. Like if we have 3 and 15, so here we had 45, right? If we have 45 and 3, it means here we have 135. Right? Are you able to follow? If we have 135 and 2, it means we have 270. If we have 270 and 2, it means we have 540. Right? Now further, if we look into this, we'll again have such numbers. But one thing we have to understand that all these numbers are composite numbers that we are getting over here. So 15 times 2 is 30, 30 times 2 is 60, then 60 times 2 is 120, times 2 is 240, right? For R, what we'll get? 25 times 5 is 125, 125 times 6, 625, 625 times is 3125, and 3125 times 5 is 15625. Fine. Now, what are the common factors in all? So basically, if you want to write the value of P, you can see it can be written as 3 times 15 times what I have taken the numbers. 3 times 15 times 3 times 2 times 2 times 2, right? The final 2. So if I want to write in the prime factorization form, this is 3 times 5. So I'll get 2 cube times 3 cube times 5. How many of you have understood this step that P is 2 cube times 3 cube times 5? Reply me with a yes quickly. Quickly. If you have understood how P is 2 cube times 3 cube times 5. Okay. let's understand what will be Q. Can you reply me? What will be Q? How many twos you can see? 1, 2, 3, 4, 5. So 2 to the power 5 times 3 times 5 for this 15, right? Correct? So you're saying it's 3 square. No, beta. 1, 3 we are getting from this 15 also. 15 was also 3 times 5, na? So 1, 3, 2, 3 and 3. So we'll get 3, 2. I hope it's clear now. After that, we have to take for R. Can you say what will be the prime factorization of R? It is 1, 2. Then we don't have a 3. Then for 5, we have 1, 2, 3, 4, 5 and 6. Now, the question is, what will be the HCF? So, if we want to find the HCF of these three numbers, we have to take only the common powers, which is 2 and 5, and their least powers. Only the common factors with their least powers. So, which option? Which option is that? Can you tell me? Option B, which is 2 times 5. So, I hope it's clear. I've tried my level best to make it very simple for you. Okay. If you want to try such great questions, you must register with us and log in for our series, and you will get a lot of such questions which are based on competency based questions as released by CBSE very recently. So you will get a paper in which 40% of the questions will be competency based, You will have case study based question, assertion reason questions, math the following can also be there. So it's not about the type of questions. It's about testing your competency upon the topic, right? The calculation competency, the thinking competency. Now let's do this problem. Which of the following cases the resulting rational number will have a non-terminating decimal form? So in this particular question, you will have to see in which of the following options in denominator we have a term which does not have any other factor than 2 and 5. But since it is asking non-terminating, so you have to see that which of the following denominators will have a factor other than 2 and 5. If you remember, we had P equal to 2 cube times 3 cube times 5. Q came 2 to the power 5 times 3 times 5. And R came as simply 2 times 5 to the power 6. Now, if you say PQ upon R, option A. So, what you will get? 2 to the power 8 times 3 to the power 4 times 5 square over R, which is 2 times 5 to the power 6. So, will it have a non-terminating decimal? Reply. Will it have a non-terminating decimal? Can you say, will it have a non-terminating decimal? No. It will have a terminating one. Very good. I got one answer, two answers as no, right? So this is not the correct option. Now going for the B one, which is P times R upon Q. So what is P? It is 2 to the power 3 and PR. So P and R we have to multiply. 2 to the power 4 times 3 to the power 3 times 5 to the power 7, right? I am adding the powers of the same basis upon Q. 2 to the power 5 times 3 times 5. So which kind of decimal it will have? Will it terminate or not? It will again terminate, you see. This is again not a correct option. Well answered by few of you. Good. Now one thing I got clear is P is the one which is having 3 as more powers, right? So now you see the C option, in which we have QR upon P. So QR is 2 to the power 6 into 3 into 5 to the power 7 upon P is 2 to the power 3 into 3 cube into 5. So here you see, even if you simplify it, you are getting a power of 3. So which is the correct option? Will it terminate? No, it will not terminate. And hence the correct option is C. So I hope you liked today's session. And if you want more of such sessions in which we discussed more of competency-based question, please let us know. So how many of you liked the session and understood the problems we have taken? Did you like the questions which we had taken today? Okay. And how was it? Did you understand whatever I took? You can please tell me whenever you find anything you want to discuss. We are always open to resolve any of your queries. Yes, it was made to be very effective for all of you. And I'm telling you, you will benefit a lot from these kind of sessions. We are going to have it on a regular basis from our platform. Please register, and I'll surely want to see all of you again. Have a good time. Goodbye. Bye-bye. And thank you so much for joining. Thank you.
A very good evening, students. If you wish to, if you wish to take up more sessions like these, so you can just visit the website, which is on the chat box, and on your relevant grade, that is grade 10, and you can just check out the whole program. For any query, you can just get back to the toll-free number, which is given on chat as well. You can also book a demo and have a personalized session with ma'am, and then you can enroll for it. So students, tomorrow will be science. So as the same as today, it was maths. Tomorrow at 6 p.m. we'll have science class. So please do join with the same meeting link, and you can attend the session.